All right, so continuing on through our pre-chapter here. Going to be getting into exponents, but before we do that, let's go back to unions with sets. So remember, we have unions and we have intersections. Intersections, the upside down U, that's that teeter-totter. It has to stay balanced, so it has to be from both. Union is it's from one or the other. Think of a marriage. You take everything of the one, everything of the other, you put it together, now you're one. So, or another example would be like a basket. It's going to catch everything. So, if it's in either one, it'll be in its union. There we go, marker working. So, starting with, we have 6 over here, 7. Now, both of them have an 8, but we only put it once. We have 9. Again, 10 in both, but we're only going to put it once. So we got an 11 and 12. Okay. So, questions with this? Again, let me know. Remember, you can always pan me, email me, send me a message on Google Classroom. Any of that works. Questions, comments, concerns. Also, remember, while you're doing these, if you need to pause it to write something down, or you need to rewind and watch something again, please do that. The videos here, help yourself. Now, getting into exponents. So, exponents have certain properties. Just like anything else, there's properties that go with it that are kind of those guidelines that we can use. So, starting with the negative exponent rule. If we have a negative exponent, basically, as long as we have a base other than 0, we don't want 0 because 0 to anything is still 0. So, it really doesn't affect that one. But, if it's to a negative exponent, what we can do is we can flip it. So if it's on top, we can move to the bottom, or if it's on bottom, we can move it to the top, and that will get rid of the negative exponent. So like for example here, if we have 5 to the negative third, we can flip it and make it 5 to the third. So moving it from the top to the bottom, or the bottom to the top, we'll change it to a positive exponent. Zero exponent rule. For any base, it doesn't matter what the number is, obviously other than 0. If we raise it to the 0 power, we're going to get 1. Whether that's 2 to the 0, 528 to the 0, whatever it is to the 0 power, automatically 1. Product rule. So if we are multiplying with the same base, so looking here, if they're both base B, if they're multiplied, all you gotta do is add the exponents, and that's the new exponent. So if we are 2 to the second times 2 to the fourth, we just take 2 plus 4, and that becomes 2 to the sixth. So if you think about it, there's 2 of them multiplied, and another 4 of them multiplied, so together we have 6 of them multiplied. Power rule. So here, if we have something raised to a power, and then that whole thing is raised to another power, where you end up doing is multiplying the exponents. So, like here, if it is 2 squared x to the third, you're going to multiply, well, first you're going to distribute to each one, which we'll get into in a moment. But that 2 squared, if you think of them, there's 3 of them that are being multiplied. So if there's 3 2 squareds, it's really like having 2 to the sixth. If we have x to the thirds, if there are 3 sets of those, of x to the thirds, we really have x to the ninth. So just know that if it's power to a power, you multiply. If it's the same base and you're multiplying, then you add. So if we go ahead and simplify those. So first off, we're going to distribute this in to each one, because that whole thing is taken to the third power. So when you have a power to a power, you have to distribute that into every term on the inside. So I would have negative 3 to the third now. X to the fourth raised to the third. And then I would have y to the fifth raised to the third. Well, 3 to the third would be 27, which would still make it negative 27, because the negative to the third power is still negative. So the x to the fourth to the third, the 4 times 3, would make this x to the 12th. The 5 times 3 would be y to the 15th. So here, when we're multiplying, again, you're going to multiply like terms, like bases. So the numbers are going to be multiplied first. So -7 and -2 would make 14. X to the fifth and an x. Think of this as x to the first. So 1 and 5 make this x to the sixth. Y to the fourth, y to the sixth. 4 and 6 would make this y to the 10th. So multiply by the same base, add the exponents. Up here, if we're taking an exponent to an exponent, then you multiply it. Now, if we're dividing, which I feel like I missed a whole page. Hey, I did, because these are front and back. So, quotient rule. So if we're dividing, we did just the multiplying, the power rule here a little bit ago. Yeah, this is really bad. The product rule. Sorry, guys. So we did the product rule a little bit ago, where if we multiply them, we added them. If we're dividing, we're going to subtract them. So if it's z to the 50 over z to the 10, we'd subtract the 50 minus 10 and get 40. Product is raised to power. So this is what I was talking about. If we have 3x in here, we have two things being multiplied, two factors. So we have a product here. Each of those is going to get that to the third. Now, this is a typo. This should be to the third here. Right? So 3x to the third. So the 3 gets to the third, the x gets to the third. And even then, wow, this is just all wrong. This should be 27x to the third. Quotients raised to powers. So if we are dividing, just like back when we were multiplying here, on the one above, if it's dividing, the top gets it, the bottom gets it, and you can square those each out instead of squaring the whole thing. So when we're simplifying, we're going to get rid of parentheses. We're going to get rid of any powers raised to another power. We're going to make sure each base occurs once. And we want no negative or zero exponents in being involved. So back to this one. So we're going to start with our numbers. -35 over 5 would end up being a -7 on the top. So x squared, x to the 6, 2 minus 6 would make this x to the -4. Y to the 4th, y to the -8th. Well, 4 minus a -8 is really like 4 plus 8 to make this y to the 12th. Now, the negative number. This is out front, that's fine. Negative in the exponent, not fine. So what we're going to end up doing is we're going to have -7 y to the 12th. And that x to the -4th is going to move to the bottom to make it a positive 4th. All right. So one more here to simplify. So in this case, we can do this two different ways. Either we can simplify what's inside here, which looks like there really isn't anything to simplify on the inside. It looks like it's already simplified. Or we can distribute the -3 in first and then simplify, which looks like that's what we're going to end up doing. I'm thinking of another example where we would simplify the inside first and then do the outside. So, going from here. We're going to have 4 to the -3rd. Power to a power we multiply. So x to the -6th. This goes to the negative y. So y to the -3rd. So this is where I was going to go with that. We could flip these right off the bat and that would get rid of the negative, or we can flip them later. Either way this works. So the y, to make it positive, we'd move it to the top. 4 to the 3rd, well, 4 times 4 is 16, times 4 again will be 64. That'll move to the bottom to get rid of the negative exponent. And then x to the 6th, moving it to the bottom. So we could have, where I was going with that, is flip this right off the bat. and then we'd have the positive exponent, and then we could distribute it and go, or we can distribute and then flip. Either way, you get the same thing in the end. Now, next thing we're going to jump to here is scientific notation. So, scientific notation is a number written where it's expressed in the form of a times 10 to the n. A is going to be a number between 1 and 9. It's going to be a single digit decimal. And then from there, I mean, the decimal can be whatever, but it's a single digit, then a decimal, and then the rest of the number, excluding zeros. So we're going to be 1 to 9. N is going to be an integer. N is going to end up being how many times you would move the decimal in order to make that the full number. So for example here, if we had 6.4 times 10 to the fifth, well, that fifth, because it's positive, means we're going to make it bigger. So we'd move the decimal once, twice, 3, 4, 5 times to make it 640,000 is the full number. So what scientific notation does is it takes a big or a really, really small number and makes it a little more easier to work with. So we always have a single digit and then a decimal and then the rest of the number. So single digit, decimal, rest of the number. And then just like here, we drop these 4 zeros to just have the non-zero numbers. Now, if there was a 0 in between the 6 and the 4, that would have to stay. Because then it's important with the place value. We need to keep them in between any non-zero numbers, but anything on the outsides we can drop. Just like here, if we move this 1, 2, 3 times, well, we're not going to keep those zeros out front. We're going to drop it so it's a single digit number. So, to write this in scientific notation. Actually, it's written in scientific notation. We're going to write in decimal notation. So what it's saying is we're going to do 6.2, and we're going to move it 7 times to the right to make it bigger. So once, twice, 3, 4, 5, 6, 7. So if I fill these in, so we're going to have 1, 2, 3, comma. So if I put those in, let's just do it that way. 1, 2, 3, comma, 62. So 62 million here. Now again, this negative out front doesn't change at all. It stays with the number. But if we move it 3 times to the left, so remember, negative, it makes it smaller. Positive, it makes it bigger. So once, twice, 3 times. So we'd add a 1, 2, and that's where the decimal goes. So we'd be negative 0.002019. So again, we have a 0 in between non-zero numbers, so needs to stay. It's not dropped, but then it fills in like such. Now, going the other way. So when we make that A, we want to put a single digit and then put a decimal point. And then we're going to get rid of any non-zero or any zero